Yeah, sorry I wasn't able to really get to doing any of these think problems yesterday. I was busy with a bunch of stuff. So I moved the due dates back to Monday so I can answer some of these questions that I got a lot of. And you still have time to do the homework and the quiz. But okay, so this is about your standard kind of problem. And all the other ones are kind of little parts of this. In fact, they kind of gave you some little more. But just to show you the basic idea, here, put this somewhere. Here, there. So this was your old formula. Standard score, x minus mu over sigma. It's the stuff you did back in, like, I think it was chapter 5, using the normal distribution and that normal CDF and inverse norm functions on your calculator. This is all the same stuff. Only difference is the formula changes slightly to this guy, right? Your sampling distribution, so your new data is the sample proportion, your new mean is the mean of the sample proportions, the standard deviation is standard deviation of sample proportions, and I guess that's where this here, so I guess I could actually say the formula looks like this. P hat minus P divided by right. So yeah, it's just taking all that and putting it together in one formula, right? Q is 1 minus P. So when we get a problem, they're going to tell you the population proportion. That we want to get a probability that something's greater than a certain one. So just like you did in chapter 5, where you did it with a piece of data, just now with sample proportions. So this problem, here, let me kind of minimize this. Oops. I'm looking at this guy. They says on average you collected about 65%. So that's going to be my population proportion, right? So I'll just kind of write that down here. So here's the problem. Just give it a couple. They say P equals 0.65. I guess I'm looking at that same problem. They're telling me that N is 100. I guess with P being 0.65 means Q is 1 minus 0.65, which is 0.35, I guess. Like basically, P is a probability of success and Q is a probability of failure. So you have a 65% chance of guessing right, you have a 35% chance of guessing wrong. So what they're asking for is what's the probability that you would get a sample proportion more than 77. So that would be looking for the probability, I guess, that your sample proportion is greater than 0.77. So I guess first thing you got to do is you got to take that 0.77 and just like before, you got to turn it into a z-score, just with this formula here. So that z is going to be then 0.77 minus 0.65 divided by square root. I got 0.65 times 0.35 divided by 100. Cool. And what is that? Let me see, I got a calculator down here. In some of these problems, they broke it up into parts, and they ask you specifically for this mu p hat, which is here, and the sigma p hat, which is here. But in this one, they're just asking for the whole thing, so. 2.52. And like I said, I did it all at once, but that down, if they ask specifically, that down there on the bottom is your sigma p hat, see, and that right there is your mu p hat. See that right here. So, but again, I just put it all together, and I get that for a z-score. So I wanted to get it more than 0.77, so I guess I'm looking over here. Normal curve, I guess 2.77 is about there, and I want to get area to the right. So in my calculator, I got to go from, what was it? Was it 2.52? Right? And I want to go onward off to something big. So I'm really bad at drawing, but it doesn't really matter here. So let's see, I'm going to go to my normal distribution. Again, just like before. Normal CDF, just like we did back in chapter 5. And I go from left to right. So from 2.52 off to something big. I don't know, I'm putting in 100, but it doesn't really matter. Something big, as long as it's more than like 9, you're in pretty good shape. And there we go. There's your probability, the area under the curve. 0.0059, I guess it is. Oh, 5 decimal places. 0.0587, I guess. Yay, okay, cool. So pretty much anytime they're talking about, when you see this, you're asking for a probability. Sorry. Anytime they're asking you for a probability, say, what is the probability? They'll pretty much always talking about doing this normal distribution thing. So anytime normal distribution, right, you take your data, I think 0.77 was my raw data, convert it to a standard score, and then get the area to the right. This is pretty much the same technique we'll do for the rest of the class here. So, once you get down, give yourself a little normal curve sketch, and we can shade it and get it going. If I look at some of the other problems now, yeah, see, here they're just giving you all this stuff, right? So they say, there's your P, your population proportion, 7% of all people. So there you go, your P hat is just P, so 0.07. And to get the standard deviation, or I guess they're saying C, standard deviation, I said sigma, but it's the same thing. But you just use that same formula, right? P is 7, I guess that makes Q 93, and N 300, so I just go through that formula. Square root 0.07 times 0.93 divided by, what did they say my N was? 300. Three decimal places, they say. Oops, shoot. Cool. 0.15. But okay, but then they just ask you on in the different parts. This is all 10%. Anyway, let me see. I guess there was another one, but I can't find it off the top of my head. So I guess I'm going to find it, and I'll make another video for that one that has slightly different questions. So here, yeah. So I'll make there will be another one coming in here in a second.